All right, in today's video, we're going to talk about functions. So functions create kind of the base of a lot of algebra and beyond in terms of what we do mathematically. So before we talk about a function is based on what's called a relation. And a relation pairs an input and an output. Okay, so if you have a function, think of something that does something. You have a machine, right? You enter in something in the machine and it gives you something out. Like say a soda machine. You put a certain code in and out comes the snack or the soda from there. And that's what a function is. It pairs an input with an output. But for it to be a function, it has to pair each input exactly with one output. So if you go to a soda machine and you hit the button A1, you don't get two different sodas that come out of that button. You only get one soda. So the snack machine or the soda machine is a good example of what a function is. Okay, so keep that in mind. This is the key. There's exactly one output. That's what makes it a function. Every input has exactly one output. Now outputs can be used more than once, but the inputs can only have one output. So if you think of a soda machine, you could have two places where there's Cokes, a Coke in A1 and a Coke in A2. But if you hit A1, you're only getting the Coke out. If you hit A2, you're getting a Coke out as well, but it's from the A2 slot, not the A1 location. Okay. Now here's some 4 examples of how to determine functions. Right. One is through ordered pairs. You may be given a list of coordinates or ordered pairs, and what we want to do is compare the inputs. Now the inputs are the x values and the outputs are the y values. So if we look here, we have the inputs of 0, 1, and 2. And we see that for each of those, they each have one specific output. So this would be an example of a function. Now, what if we had something like this? If we had 0, 3, and then we had 0, 1. Well, because we have two inputs that are the same, this would be not a function. Okay. All right, if we look at the table, we see that we have 3 inputs, 0, 1, and 2, and they have outputs 3, 4, and 5. Because the inputs are not repeated, and there's exactly one value, this would become a function. To make this not a function, we could change this to say 0. Now we have 2 0 inputs, and that would make it not a function. Now over here, this is something new and that students may have not seen up to in their math background up to now. Is called mapping. And what this does is you have an input over here and it maps to an output. So 0 could map to 3. So if you hit in 0, it will go to 3. 1 might go to 5 and 2 might go to 4. So what you're looking for here is that every input only has one arrow going somewhere else. As soon as I put a second arrow here, this double arrow makes it not a function. So to make it a function, you need one arrow from each of the inputs. Okay? Now it is true that you could have 2 outputs the same. So say 1 went to 4 and 2 went to 4. This would be like the Coke example. This would be Coke. This would be A1, this would be A2. Can you hit both of these buttons and get a Coke out? You can. Okay, so keep that in mind. The Coke will be on the output, the input would be the code on the vending machine that you use. All right, the last one would be a graph, and there's many types of graphs you can have. One example would be something like this. This would be a linear function. Okay, and it is because the vertical line test is a way for us to determine if a graph is a function. It's a visual method. And so what we want to do is draw a vertical line and see that that vertical line only touches the graph one location. So no matter how you draw a vertical line, it's only going to touch it in one location. If I had a graph such as this, okay, and we drew a vertical line, we will see that it actually touches the graph in 2 locations. This would not be a function. Okay? We may see graphs that are what we call discrete, and you may have some points that are closed and points that are open. So wherever you have a graph point, okay, if you can draw a line through it, it's a function, as long as it touches that location once. But what if I had another point here? So if I have 2 points, this would make it not a function because this line touches those points twice. Now, this is important to keep in mind, is the open circle and closed circle, which we've seen in inequalities. But when we graph points, normally the circle is always filled in, but now we may have points that are not filled in. So for example, you need to have 2 filled in circles, 2 filled in points with, in a vertical line to make it not a function. If, for example, one of the points was open and one of the points is closed, even though there's 2 points, that's still a function because this is equals to that value and this is not equals to that value. Okay, so this one would still be a function. So again, you need 2 closed points for it to be not a function. Okay, when we have inputs and outputs, we have available domains and available ranges. Now domains are going to be the x values and y's are going to be the ranges. So if we look up here at this example I try to use throughout, the domain values would be 0, 1, and 2. And sometimes textbooks will use these like lip ellipses to tell you that this is a set of domain of 0, 1, and 2. So this is the set. For the range, we're looking at y values. And this would be 3, 4, and 5. Okay? This would be an example of discrete. All right. Now, what about if we had, go back to our graph example, and what do I mean by continuous? If we had a graph say we had this here, which is a function, because if we draw a vertical line, it only touches that line in one location. We would start at -2, and it would continue on forever. Okay, so what we would do in this case is what are the available x values that we can use? Okay, so in this case, the x value is greater than or equal to 2. So any x value greater than or equal to 2 would be in your domain. For y value, we would need to determine where it's at. So for example, if this y value is 1, then our y value will be greater than or equal to 1 in this case. Now, we may see examples of domain and range that are in compound forms. So maybe we have something like this, where x is between 3 and 8, for example. So if we had an example like that, it might look something like, if this were 3 and this were 8, and there's our function, okay? That would be an example of this domain. Now the range, say this was 4 and this was 10, then our y value would have this range, okay? All right, now, last thing is this. When you have a function, all right, one thing is going to depend on the other. So in class, we did the ramp rule, right? We created a ramp, we marked up the ramp, how far we wanted to roll the ball, we let go of the ball rolled down and hit the floor. Well, the distance on the floor depended on, so the floor depends on the ramp height. So the independent variable is going to be your input. Okay, so the input is the independent variable. The output is going to depend on the independent variable. Okay, so what soda pop you get out depends on, so the output depends on what button you push. You can push any of the buttons, but if you want a certain one, you have to hit the certain button. Okay, so the dependent variable will be the output or the y values. Okay, so with these questions, you need to think about what's happening, what is changing, what is given to you, and what changes as a result of it. Okay, so this is your basic function lesson with vocabulary. Again, functions have exactly one output. There's 4 different ways to talk about functions. We went through domain and range with discrete domains and ranges and continuous domains and ranges. And then we talked about independent variables. So from this, we're going to create a building block of functions where we'll go into linear functions, and we can go into polynomial functions, and we can go into a variety of other functions. So this creates our backbone of a lot of more mathematical study coming ahead.